Okay, are you going to verbalize some stuff tonight?
I thought I emailed you.
Oh, you did? Okay, here, let me open it up. Did you do it recent, or?
It was like an hour ago.
Yeah, I have not gotten it. Did you send it to David Cowan 1949?
Yeah, the one I send it to pretty much every day.
Right. No, I know. Trying to figure out why I would not have gotten it. Google Mail has actually given me a little problems today.
Sorry, try re-emailing it.
Yeah, if it's stuff you can't verbalize, yeah, why don't you try that? Let's just start there. Yeah, I noticed that I had some phone, the email would come through on my phone and it wouldn't come through on Google Mail for like 20 minutes later.
Yeah, that happens at school a lot on our Wi-Fi. School Wi-Fi.
I hate to spend too much of our half hour waiting for it. Can you give me one to start with while we're waiting for it, and that you could verbalize maybe?
Yeah. So 8 over x plus 2 and then plus 8 over 2 equals 5. And then you have to find what that equals.
You have to solve that equation for x?
Yeah.
Is that all you have to do?
Yeah, and then find what x can't be for it to be.
Okay, what can't x be? There's one thing that's real clear. We can see right off the get-go. What's the one value x cannot be?
-2.
Okay, so let's start there. And now let's solve this equation. First step. Did I write it correctly? It doesn't seem like that is what they would give you, but...
Yeah,
it's
correct.
Okay, what's first step? Ah, yeah, I got it now. Here, let me bring up that file. We're looking at 24?
Yeah.
Okay.
Yep.
What's a good first step?
It would be multiply the 8 over 2 by x so that you can...
Let's make it easier.
Combine.
We don't need to do that. Let's make it easier. What's 8 over 2 equal to?
4.
Okay, so let's start there. Now what?
I don't know.
How do you isolate x? We're trying to isolate x. So you want to get rid of everything else that's around there on the same side of the equation. What's the first thing I can move?
4.
Okay.
Positive 4.
So now I got 8 over x plus 2 equals 1. Now what can I do?
You can multiply it by 2.
Well, you want to multiply it by x plus 2. You get rid of denominators by multiplying by the denominator. So I want to multiply that by x plus 2, and this side by x plus 2 turns that into 8. So I got 8 equals x plus 2, x equals 6. Okay, now solve the equation by using lowest common denominator. All right, I guess I didn't read the instructions. That's why they've given you this strange 8 over 2. They didn't want me to solve it by turning 8 over 2 into 4. So let's go back and do it the way we were supposed to do it. That was my mistake. What's the lowest common denominator?
X plus 2.
Does 2 divide into that evenly?
Yeah.
No, it doesn't. No, it doesn't. X plus 2 divided by 2 does not equal
Yeah.
something.
Does not equal X.
So what is the lowest common denominator going to be?
X plus 2.
Times
2?
Yeah. In other words, if x plus 2 isn't it, the only other possibility is the product of these two things. So notice that this common denominator is divisible by x plus 2 and by 2. That's what a common denominator has to be, is divisible by both terms. Now, this is really the hard way to do it, if you'll notice. It was much easier turning that into a 4. What goes here?
16.
What goes here?
8x plus 16.
Combine.
So, yeah. So, 8x plus 32.
Simplify.
It would be 4x plus 16.
All divided by x plus 2.
X plus 2.
And this is all equal to 5. Really the hard way to do it. Next step.
Then you would multiply.
What's the next line?
X.
Give me the next line. I'll write it.
So 4x plus 16 equals 5x plus 10.
Okay. So solving that for x.
X equals 6.
Yeah. Clearly we had to get the same answer. Alright, let's see. Do we need to do 22? What's this x equals 0 here?
That's just what it told us the answer was. Like that.
That's not the answer for 21.
No, I know.
That's what x cannot be. But the thing is that you don't need to worry about what the domain is here. Nowhere does it say, tell me what the domain is. In other words, each one of these, we're going to be able to come up with an answer for x. So we don't need to say it's not equal to 0. I know it's not equal to 0. It's equal to 2 in 21. If x is 2, then 3/2 plus 1/2 equals 2. So x equals 2 is your answer here. Okay, let's do 22. I guess you started on 24. Is there a reason we didn't start on 22 or 21?
No, it was just I'm not really sure why we did that. But
Okay, what's the best thing I can do to start here?
you could multiply it by x, so
That's what I like as a first solution, but that's not solving it by using a lowest common denominator. At least, I don't think it is. Maybe they would say that it is. Let's do it by adding those two things over there. What's the lowest common denominator?
x.
Goes here.
X squared.
Now I can solve it by doing what?
Multiplying the 3 over x.
Okay, hold on. Let's go ahead and add these together.
Oh,
So that's what our equation looks like. 3 plus x squared over x equals 4. Now what's the next step?
multiply the 4 by x.
Multiply both sides of the equation by x. Remember, you can't just multiply the 4. You have to multiply, whatever you do has to be done to both sides of the equation. So when I multiply the right side by x, it gives me on the left and gives me on the right. Now how do I solve that?
Can't you divide 4 from 4x?
What are we looking at here? It's important that you always recognize what that is when you see it. What's that called?
No.
It's quadratic.
Oh.
How do we solve quadratics? What's the one key to solving a quadratic that we really don't do to much else?
Everything on one side.
That's what I was looking for. So what's the next line?
3 plus x squared minus 4x.
Okay, let's put it in order. Equals what?
0.
Okay, now what?
Now, you would factor
Okay. Into?
would be 3 and 1, negative 3 and x minus 3x minus 1.
Okay. So my two solutions are
X plus, or 3 and 1.
okay. Now let's just check and make sure we don't have any problems. When x is 3, I get 1 plus 3 equals 4. When x is 1, I get 3 plus 1 equals 4. So both solutions are good. Do this one. I really kind of hate the fact that they are forcing you to solve it this way, because that's not the best way to solve these. The best way to solve these using a lowest common denominator isn't, maybe they're just giving you practice on lowest common denominator. So,
Yeah.
would they consider, here's my problem, is that my first step here always is to multiply both sides of the equation by the lowest common denominator, rather than solving the left side of the equation by lowest common denominator. It's a little quicker. It's one step quicker. What is the lowest common denominator?
2x.
Good. So we'll do it their way. Goes here.
9x.
So now I can get rid of one of these, the negative sign, move it up, and extend that. Now what's the next step?
Then you move. Wait, you divide it 6x by 2x. Or divide both sides by
Why?
multiply.
Why divide?
I was thinking something else. Multiply both sides by 2x.
Okay, what's the next line?
3 minus 9x equals 12x squared.
Okay, and the next line?
12x squared minus 12x squared
Keep that coefficient positive.
Okay, so plus 9x minus 3.
Okay. In other words, if we'd have done it the way you wanted to, we would have just had negative signs, opposite signs than what we have here, and then we would have had to divide both sides by minus 1. So I tried to save a step by, instead of moving this 12x squared to the left, let's just leave it over there and move everything else over with it. Okay, let's factor that.
Could you factor out a 3
Okay,
from all that?
that's good. Yeah, I like that. I didn't see that. So it turns into 4x squared plus 3x minus 1, which is going to make the factoring a lot easier.
So
Don't try to do the whole thing at once.
So it would be x and x.
Does x and x multiply to 4x squared?
No, it's 2x.
Okay, that's one possibility, 2x and 2x. Recognize that's not the only possibility.
Yeah.
What are the signs?
It's different. One's positive, one's negative.
Does that work? Because there's only one set of factors for 1. Okay, so that doesn't work. So let's go back to the drawing board and refactor the 4x.
So it would be 4x of x.
Okay. Now the signs are opposite, but now it matters. That could be different. In other words, once I get a different coefficient over here than I have here, now I can't just write plus minus because it might be minus plus.
Right.
Where's the 1 go?
You go on the right side. With
which sign?
Positive.
Over here?
Yeah.
Yeah, because that I can see is going to give me plus 4x. And then the other one goes there. So let me erase that part and do the inside. You got minus x plus 4x gives you plus 3x, which is our middle term. So we have factored it correctly. And that might be one where the California method might have worked a little bit better, but I don't honestly think so. Have they taught you the California method?
Yes. Yeah.
Do you use it or do you use my method?
I usually use that method.
California method?
Your method more. No, your method more because I feel like I don't know. To me, I feel like California method takes longer.
I do too. I feel exactly the same way. I have another student that I've had kind of his mother actually, at the end of our last session, she came down and she said, I think he's being very confused between your method and the California method. I didn't know what to say. I came back the next day and I said, factoring is maybe the most important skill you can get out of algebra. You've got to be able to factor. If you have any hope on passing a final exam, you've got to be able to factor. So I said to him, well, if you can't use the California method, then you need to learn my method. And he said, I know the California method. So I gave him a problem. I said, factor using the California method. He did. I said, enough said. You're good to go. I don't care what method you use. I really don't. I have no vested interest in you using my method over the California method. The only thing I care about is you be able to factor however you know how to do it. The California method has just as much trial and error in it as my method does, I believe. I don't think there's any, there's still a lot of trial and error in the California method, just like my method. Mine seems to be less complicated to me, but I'm curious as to my students, because I do kind of have students, and I'll be teaching them for a full semester, showing them my method over, and then I think they go into a test and they try to remember the California method. Well, that's not what you want to do. If you're going to use the California method, then I'll start using it when we do factoring. I want to make sure you use whatever method you're going to use when you go in and take that test.
I'll probably use your method.
Right.
I usually use that method probably 95% of the time.
You know, for the level of difficulty of the problems they're giving you, my method works really good, almost every single one of them. Now, if I had a problem like this, 12x squared minus x minus 12, that could be tough to factor because there are so many different factors of 12 here and here. So my trial and error method, I'm going to have to run through all kinds of possible factors. But I think you'd have the same problem using the California method on that right there. In other words, it wouldn't be really any easier. It's just, it's structured slightly different. But in general, when they give you problems that need to be factored, and the first term is not x squared, but something like 4x squared, they're not that hard. Notice the constant was 1, so there was really the only thing I had to decide how to break up was the 4x squared. Is it 4x times x, or is it 2x times 2x? So there was trial and error, but not much of it.
Yeah.
All right. Let's see. We did 24. Should we look at 20?
Can we actually jump down to either like 30 or 31?
For sure. Absolutely.
30, any of the bottom three?
Okay. Let's do, let me just write it. And then I can blow my page up so that I have some room to write. Oh man, this is the one where I really hate the way they're doing it.
You can just do it the way you'll do it.
When I see, now this is a little strange because this is exactly opposite of the way I solve complex fractions. Didn't we do complex fractions in our last session?
Yeah.
And I suggested you do the numerator alone, and then you do the denominator alone, and then you do them together. Well, when I see a problem like this, my inclination is there a factor which will get rid of the denominator all at once? Is there something I can multiply by to get rid of that denominator, and that denominator in one step? There is if I factor that first term. Pull an x out of there. Now what can I multiply by to get rid of all denominators in one step?
2?
What would it take to get rid of that? What would I have to multiply by? By that denominator.
Yeah.
By x times x minus 2. Would that get rid of that denominator?
Yeah.
Would it get rid of this denominator?
Yeah.
Then let's do it. In other words, one step we lose all three denominators. If that isn't the simplest thing to do, I don't know what is. So let's do it. That leaves 10 there. What does it leave here?
4.
Remember, we're multiplying everything by that denominator. Every term in the equation.
Oh, so it would be 4x minus 8. And then 5x.
Solve that.
It would be x minus then equals 2.
Now, it's harder to find much of an easier solution than that, right?
Yeah.
Let's just look at it from the other way to do it. The other way to do it would be much like the complex fractions, where I would just do this by itself. Well, common denominator is still that. Now we combine the left, and we get 4x plus 2 all over x times x minus 2 equals 5 over x minus 2. And now we can see that that's going to cross out with that. And now, what the heck did I do? I lost my spot. Oh, down here. Okay. Now we got 4x plus 2 over x equals 5. Multiply both sides by 5x. We get that. And now we get x equals 2. So, how many steps was that? We had 1 step there, 2 steps here, 3 steps there, 4 steps to get that solution. Whereas the way I did it the first time
was 3.
Yeah, the first step got rid of all the denominators, and then actually it was 2 steps. Because the first step eliminated all denominators, and then we could combine constants and variables in 1 step to get x equal 2. So you can maybe see the advantage of doing it the first way I did it. In other words, rather than think about adding 2 fractions here, think about ridding yourself of the denominator all in 1 step. And if you think about it, that's real similar to when we had all of this 1 over 3 minus x minus 1 over x minus 3 all over x over 4 plus 3 over x. In other words, when I'm doing a complex fraction, they wanted you to come up with a common denominator that would take out all 4 denominators in 1 step. I didn't like doing that because that looks too hard. And yet it's exactly the same thing. So you could do either type problem either way. In other words, the way I prefer to do this problem is to do the numerators alone, do the denominators alone, and then flip and multiply, and then reduce. But notice that that method is kind of the same thing as doing the left side all alone, and then moving forward. Whereas my favorite step here is to find the least common denominator that gets rid of all 3 denominators in 1 step. It's just more complicated looking when you have a complex fraction.
Yeah.
I mean, it seems more complicated looking. I know it's 6:30, but what's the first step? Under that premise, what's the first step going to be on 31? Well, there's a couple of them you could do.
Could you cross out, and so it'd be only 4/1?
Yes. You absolutely could. Wow. Why is this on here? Because they want you to solve it by least common denominator.
Yeah, next to number 30, that one's easy.
32?
Next to number 30, 31's easy.
Yeah. Oh, I see. Yeah. Next to 30. Yeah, you're right. It's harder. The thing to do is to factor that. If you factored 30 first, you would see it was x times x minus 2, and we can see that that's going to be the common denominator either of the left side of the equation or the whole thing. So it was the same lowest common denominator for there. But, yeah, 31 shouldn't even be on there. What am I going to multiply 32 by? Wow, 32 shouldn't be on there either.
But just multiply it all by 2 to get rid of the denominator.
No, 2 won't get rid of the x plus 4.
So just multiply it by x plus 4.
X plus 4. After I've factored that out, because that's going to leave me a 2 times x plus 4, which means I really could just cancel. No, you can't. You got to be a little careful with that. Notice that if I have this, I cannot just cancel the x plus 4s.
Yeah.
Because I got this 2 right here. In other words, I could multiply every term by x plus 4, and that's what I would do. And that gets rid of this denominator, gets rid of that denominator, and then I merely have this as multiplied by x plus 4. And then I can solve it. All right. That take care of you for tonight?
Yeah, that makes sense. And I don't need Wednesday.
Okay.
Because we're not doing anything new. We're just taking a little quiz.
That's fine.
And
I will be very busy. I'm sure I'll fill that spot, so thank you for telling me. And so I'll see you Saturday at 4. I won't see you. I'll talk to you.
Yeah.
All right, Mitch. Have a good week.
You too.
Bye-bye.